Welcome to this exploration of hydrogen, the lightest and most abundant element in the universe. This remarkable element carries the atomic number 1 and is represented by the symbol H. Its significance cannot be overstated, as it makes up approximately 75% of all normal matter in the universe. Imagine the vastness of the cosmos, the twinkle of distant stars, the life-giving water on our planet, and the complex organic compounds that make life possible. In all these, one common element is present: hydrogen. It's a key player in the grand scheme of things, from the smallest molecule to the largest star. Hydrogen's roles are many and varied. It's a crucial participant in acid-base reactions, forming covalent bonds with non-metals, and it's not just in nature where hydrogen shines. It's also a workhorse in many industrial applications. Think about the processing of fossil fuels, the production of ammonia, and the workings of fuel cells. Hydrogen is there, facilitating and making these processes possible. But hydrogen is not a one-size-fits-all element. It exists in different forms, known as isotopes, each with its own unique properties. The most common isotope of hydrogen is protium, which, unlike its siblings, has no neutrons in its nucleus. But let's hold on to that thought. In our next segment, we'll delve deeper into the world of protium, the neutronless isotope of hydrogen. And from there, we'll journey to the fascinating realm of deuterium, another hydrogen isotope, with one neutron, which plays a critical role in heavy water. Now that we understand the basics of hydrogen, let's explore its isotopes, starting with protium. Protium, the most common isotope of hydrogen, is unique in its simplicity. Let's take a moment to understand what an isotope is. You see, isotopes are versions of an element with different numbers of neutrons. So, when we talk about protium, we're referring to the isotope of hydrogen that has no neutrons. Yes, you heard that right, no neutrons. Protium is the hydrogen that we all know and love from the periodic table. It's colorless, odorless, tasteless, and highly combustible. It's also the lightest element, making up approximately 75% of all normal matter in the universe. Pretty impressive for something so simple, right? Protium primarily exists as diatomic molecules, meaning it's usually found paired up with another hydrogen atom, forming H2. It's found in stars, water, organic compounds, and more. It plays a vital role in acid-base reactions and forms covalent bonds with non-metals. Its simplicity and abundance make protium a key player in many industrial processes. It's used in fossil fuel processing, ammonia production, and fuel cells. However, despite its wide usage and importance, protium is surprisingly unreactive compared to other diatomic elements due to its strong HH bond. This characteristic can be accurately calculated using quantum mechanics, displaying the fascinating blend of simplicity and complexity that protium embodies. Protium helps us understand the basic structure of hydrogen, but the story doesn't end here. Let's move on to another isotope, deuterium. Remember, we won't be discussing the third and unstable hydrogen isotope of tritium, which has 2 neutrons. That's a topic for another day. For now, let's dive deeper into the world of hydrogen isotopes. Deuterium, another isotope of hydrogen, brings its own distinct characteristics to the table. Unlike protium, the hydrogen we're most familiar with, deuterium has not just a proton, but also a neutron in its nucleus. This additional neutron makes deuterium twice as heavy as protium and earns it the nickname heavy hydrogen. But let's be clear, deuterium isn't a version of hydrogen itself, it's an isotope. Now, you might be wondering, what's an isotope? Well, isotopes are versions of an element that have the same number of protons but different numbers of neutrons. Hence, protium, deuterium, and tritium are all isotopes of hydrogen, each with a varying number of neutrons. But let's not delve into tritium today, as it's a bit of a wild card with its 2 neutrons and unstable nature. Deuterium, however, is stable and quite intriguing. It plays a crucial role in nucleosynthesis, the process that produces new atomic nuclei from pre-existing protons and neutrons. Deuterium is also present in stars and comets, making it an important player in our universe's cosmic narrative. But deuterium's influence doesn't stop there. It has a significant impact on fields such as spectroscopy and nuclear magnetic resonance studies. Spectroscopy studies the interaction between matter and electromagnetic radiation, and deuterium's unique properties make it a valuable tool in this field. Similarly, in nuclear magnetic resonance, which is used to determine the physical and chemical properties of atoms, deuterium offers distinct advantages due to its unique nuclear properties. Deuterium highlights the rich diversity of hydrogen's isotopes. Now let's look at how deuterium plays a role in the formation of heavy water. Heavy water, also known as deuterium oxide, is a fascinating substance that owes its existence to deuterium. In the world of chemistry, heavy water is a unique variant of the water we're all familiar with. What sets it apart is that all of its hydrogen atoms are not just any hydrogen, but deuterium, an isotope of hydrogen with one neutron. In other words, it's still water, but with a weighty twist. The presence of deuterium instead of the common hydrogen-1 isotope gives heavy water its distinctive nuclear properties. These properties, in turn, make it a valuable resource in certain industries, especially those involved in nuclear reactors. Now, it's important to note that heavy water is not a version of hydrogen. Instead, it simply contains deuterium, the isotope of hydrogen. It's like a special guest star that brings its own unique traits to the show, changing the dynamics and creating fresh and exciting storylines. And just like a guest star, deuterium doesn't overshadow or replace the main character, hydrogen. It simply adds a new dimension, a new layer of complexity that makes the story more interesting. This is the beauty of isotopes. They don't change the nature of the element, in this case hydrogen. They simply offer a different perspective, a different way of looking at the same element. So, when we talk about heavy water, we're not just talking about a version of hydrogen. We're talking about a version of water, a version that contains deuterium and brings its own unique properties to the table. Heavy water is a testament to the multifaceted nature of hydrogen's isotopes and the intriguing chemistry they can create. It's a reminder that even the most basic elements can surprise us with their complexity and versatility, continually challenging our understanding and pushing the boundaries of scientific discovery. We've taken a journey through the fascinating world of hydrogen and its isotopes, but there's always more to learn. The beauty of this digital age is the wealth of information right at our fingertips. To access more details, you'll find a full video description below. If you're using a smartphone, you might need to tap on the word "more" a few times to reveal the whole thing. Now, in this description, you'll find a treasure trove of links leading to the informative articles that provided the foundation for this video. These articles delve deeper into the intriguing world of hydrogen, its isotopes, and their fascinating applications. As we continue to explore the wonders of the universe around us, your support is invaluable. If you found this video informative and engaging, we encourage you to like it, share it with your friends, and subscribe to our channel. Don't forget to hit the notification bell. That way, you won't miss our future videos. Also, feel free to leave a comment below. We're eager to hear your thoughts, and we appreciate your feedback. Remember, to see the whole description on a smartphone, you may need to click on the word "more" multiple times. And if you're watching this on a TV, you'll need to use a laptop or mobile device to click on the links. Thank you for joining us in this exploration of hydrogen and its isotopes. Stay curious,